Apple Nighthawks, Module 5, Lesson 6. So this is really similar to Lesson 5, where we were using area models to decompose to show equivalence. Remember, equivalence means equal. They have the same value. The only thing different in this lesson is is going to ask us to change this into twelfths or change this into tenths. And we have to use our math skills, our multiplication skills, to understand, well, what are we going to have to do? Okay. So here we are. Here's our first one. And notice what we have. We have two of them are shaded. Okay. So we know we're going to have 2 as our numerator. And it is 2 fifths. So there's 1, 2, 3, 4, 5. So we have 2 fifths. And it wants us to decompose that into tenths. So kind of like I was doing last time, okay? We know that our new denominator says right here, it says tenths. That's what our new denominator needs to be. So when I put that here, we're going to use our multiplication skills to help us figure out how many more rows do we need to make to decompose. So look at this, 5, we're changing that to 10. So 5 times what gets me 10? 5 times 2. So here's my trick with this. We need to make 2 rows to make this work. So to make 2 rows, we only need 1 horizontal line. Okay. And then we always want to check it. So did that make it into tenths? So now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And when I say rows, I mean up and down on the side. So there's, my mouse keeps going. So there's 1 row, 2 rows. So because I multiplied by 2, I needed to make 2 rows to make it into tenths. And I have 4 shaded. So 2 fifths is equal to 4 tenths. And it wants us to do that multiplication sentence like we did last time. So 2 fifths is equal to, how many tenths did we have? We had 4. So we're going to take 4 times 1/10. Remember, clicking and dragging, I know, can take time. But if you need to do this on paper, you can. There's some extra, the parentheses and stuff down here. I'm not going to ask you guys to do all that. They decompose it and rewrite the sentences a few different ways. I'm not going to show that to you in video. We can do that in class time. Okay, so this is all I'm going to ask you guys to do when you guys are doing on your practice. I want you guys to decompose it into whatever it's asking. Show me the equivalence and then show me the multiplication sentence. Okay, so 2 fifths was equal to 4 times 1/10, because 4 times 1/10 is 4 tenths. And as we just showed, that's equivalent to 2 fifths. Okay. All right, let's do another one. All right, so first, let's figure out what do we have. We have 1, 2, 3, 4. 4, so we're working with fourths, and 3 of those are shaded. Oh, I haven't been putting it up on the top. So we can show right here, well, this is showing me 3 fourths within the bracket, okay? So now I'm gonna show 3 fourths over here on the side. And it wants me to decompose that into twelfths. So again, our basic multiplication facts are going to come into play. So how can I convert my 4 into 12 using multiplication? 4 times what equals 12? 4 times 3. So we're going to need to make 3 rows. We break this into 3 more rows. That's going to decompose this into twelfths. So to make 3 rows, I'm going to need 2 horizontal lines. Okay. 2 horizontal lines, so that made 3 rows going top from bottom. That's what I'm just saying, rows. So if I had to multiply by 3, I wanted to make 1, 2, 3 rows. Okay, so now I should have 12. So let's double check it. So we got 3, 3, 6, 9, 12. So we just decompose that into 12s. And how many 12s do we have now? 3, 6, 9. So 3/4 is equivalent to 9 twelfths. So we can put 9 twelfths on our new bracket, showing that that is what we converted. 3/4 and 9 twelfths are equivalent. So if we were to show this as that multiplication sentence, remember that's all I'm asking you to do. I don't want you to do, you don't need to do the addition unless you prefer that way. 3/4, but I would much rather do multiplication instead of writing 9 twelfths out individually. 3/4 is equal to, so how many twelfths did we have? We have 9. So we're going to take 9 times 1/12. So if you are confused on how we convert something into twelfths or how we convert something into tenths, so I'm trying, if you look at this, if you set this up how I am, 3/4 is equal to blank twelfths because we know we need twelfths. You just need to think multiplication. What times 4 equals 12? That's what we're doing, really. We're multiplying the amount of units we have to convert them to 12s. Okay? We'll do one more together. Okay. So this is already giving us the equivalent fraction. So they want us to represent that in the tape diagram. Okay? So they're starting with 3/5. So we're going to need fifths. 5 of these guys, and 3 of them need to be shaded. So there's 3. Oh, see, this can be a little tricky. 4, 5. And remember, you can draw these out 100%. I don't mind. I know how tricky it can be. Clicking and dragging. And if you don't have a mouse, like I was talking to my small group today, if you don't have a mouse, then it's even harder. So if you don't have a mouse, oops, I did one extra shaded. I'm going to take this guy out of there. And this guy. So if you don't have a mouse, then I would almost prefer you to do it on paper and just send me a photo, because without a mouse, it would definitely be hard. Okay, so there's my 3/5. So looking at this, 5 times what equals 10? 5 times 2 equals 10. So I need to decompose and make this into 2 rows across, and that's going to show me those 6 tenths. Okay, so now I have 2, 4, 6 of the tenths represented. So if I show this as a multiplication sentence, I'm going to say 3/5 is equal to, how many tenths did we end up with? We ended up with 6 tenths. So 3/5 is equal to 6 times 10, times 1/10, excuse me, times 1/10. Okay. All right. Like I said in the last video, we're not always going to use these area models to represent this. So if the area model is like, oh my gosh, what are we doing? That's really confusing, but you understand the multiplication part of it. You understand that, oh, okay, so if whatever I do to the bottom, I need to do the top. So 5 times 2, 10. 3 times 2, 6. 3/5, 6 tenths, that's equivalent. If you're understanding that multiplication piece, then you're on a good track, okay? The point of the area models is just for you to be able to see what's happening Why is that equivalent? Why, when we decompose, even though 10 is larger than 5, that they're the same? That's the whole point of area models, okay? All right, you guys, great job today. Keep working hard, and I will see you guys soon.